But the main reason for that is 3,000 people self-evacuated Building 2 between 8:46 and 9:03 before that building was hit. And what helped such a large number of people to evacuate was the functioning elevators in that building. So self-evacuation without anybody telling them to evacuate is really what saved 3,000 people, and the rate of evacuation was faster. After that, things were the same in the two buildings. Once both buildings had been hit, and in the last 20 minutes before each building collapsed. So one of the buildings collapsed around 10 o'clock, 20 minutes before that. The other building collapsed around 10:30, 20 minutes before that. The rate of evacuation had become 1/5 the prior rate. So it had slowed considerably in both buildings to 1/5 its earlier rate. Which tells us that the egress capacity, which means the number and width of stairways, was adequate to accommodate the survivors in those buildings for those seeking and able to reach and use those undamaged stairwells. With that qualification, the stairwell capacity was adequate. With regard to counterflow, even though some individuals pointed out that the counterflow was an issue, which means for them, firefighters coming up or emergency responders coming up, we found through our overall analysis that it was not a significant factor in the total evacuation time in World Trade Center 1 when compared to other factors. And I think the factors we are talking about here are evacuation initiation delay, the time it took before people were, the time it took from the time of impact until they got into the stairway. That's the initiation delay. Did they go right away, or did they gather belongings, or did they talk to somebody? We found that the average time there was somewhere between 4 and 7 minutes before they actually got to the stairwell. The bulk of the time was spent in the stairwells coming down. And so that's important to keep in mind. Second thing, we used current models, what are known as egress models, which are, by the way, used in design of buildings, supplement what's in the codes. And based on, if the buildings had 25,000 people each, which would be a full capacity for those buildings, and not 8,500 people each, the evacuation would have required 4 hours. And our current projection is that as many as 14,000 people may have lost their lives based on rough estimates using those models. Now, there is some misimpression that's been created about the models, and their adequacy or lack thereof. The misimpression is that the main concern with those models relates to the evacuation initiation delay and not being able to model it. That's not the case. These models, by the way, are very rudimentary models for the most part. They do not adequately account for human behavior in an evacuation, which is a very, very important component. They're very sensitive to the initial conditions, and which, by the way, requires a lot of good data about how things started in the buildings, which is often difficult to get post facto. But I think the main delays that we see are once you get into the stairwell, what happens? Clearly there's an issue of crowding in the stairwells, there's an issue of people taking time to rest in the stairwells, and there's an issue of people with mobility impairment and counterflow from firefighters that can influence those results. So those kinds of issues are not adequately captured in the models. So actual times that the models actually predict evacuation much sooner than we found was the case on 9/11. So very often these models are used as part of design. And I think it's important to recognize those. I'm not saying they were used in the World Trade Center towers, but they're used to help in the design process. But we did find that the evacuation rates of the occupants in the buildings were about, once they were in the stairwells, it took about 48 seconds per floor coming down the building. So if you were in the stairwell, you spent 48 seconds per floor coming down, which actually is half the slowest speed measured in non-emergency conditions. So it's slower than what people had measured under non-emergency conditions. You would think under emergency conditions it would be faster. Condition of the stairwells. The stairwells in building 1 were very close to together in the center. Are we losing time here? What's the notice? I understand quarter hour.
Just Shyam, just keep going.
Yeah.
Finish it quickly.
We had pretty close stairwells in building 1 and the impact floors. That's about as close as they ever got in the buildings. In building 2, the stairwells were pretty far apart, and these were as far apart as they ever got in the buildings. And it turns out that all 3 stairwells in building 1 were compromised in the impact region, so nobody from above the impact floors could get out. While in building 1, this stairwell here, stairwell A, actually left, we know, at least 18 people from above the floors of impact to get down above that, from above the floors of impact. And we do know there was damage even here, and it was at least marginally passable for some time. I think the big issues here have to deal with, in the 1968 code, the code required the stairwells to be as far apart as practicable. The stairwells certainly separation ranged from 70 feet to 200 feet, demonstrating that large stairwell separations in towers were practicable. However, the 2001 New York City Building Code requirement is slightly different. It does not use the as far as practicable wording, so therefore it actually meets is consistent with the 2001 code requirement. The advantages of moving stairwell locations on the floor plan usually include reclaiming core space for occupant use, above those terminated elevator shafts, and overcoming obstructions posed by equipment installed on the mechanical floors. The general issue here is the priority assigned to remoteness of stairwells within the core, where there's a lot of competition for the space there. And we will certainly be considering this as we formulate our recommendations for June. With regard to occupant preparedness, I think 2/3 of the surviving occupants reported having participated in a fire drill in the 12 months prior to 9/11, and 93% were instructed about the location of the nearest stairwell. However, over half the survivors had never used a stairwell prior to 9/11. And there is a specific New York City Local Law 5 which prohibits requiring occupants to practice stairwell evacuation. I guess if they choose, they could, but as part of a formal drill or training, you could not require occupants to use it. And there are probably very good reasons to use it, because especially when you have to become familiar with the entire evacuation route. If you have transfer hallways that you're not aware of, you will become aware of that. And certainly you might be able to test out whether your physical skills. Just think about a lot of us, if you try walking down 10 flights of stairs, you could test whether or not you could walk down 40 flights of stairs or 60 flights of stairs. It'd be probably challenging for most of us, even those who actually do marathons. So I think these are very important parts of evacuation training and preparedness. We've talked about roof evacuation. and the fact that the standard protocol in the buildings were for exiting down at the bottom of the stairs, not to use, not to seek out roof rescue as a standard means of escape. We've looked at the 1968 New York City Building Code, and our analysis of that clearly suggests that the access to the roof that is required in the code is not necessarily for emergency evacuation of occupants, especially since it talks about, the current code talks about using ladders and scuttles to get access to the roof. So in terms of general capability and policy, due to the limited capacity of typical helicopter and travel time, roof rescue was never considered a viable strategy for general evacuation. Even if it had been possible for a helicopter to gain access to the roof, despite the smoke and the intense fire, the intense smoke and the fire conditions, possibly only a very, very small fraction of a large number of people trapped above the impact zone could have been rescued on 9/11. With regard to the public address system announcements, I think in the case of Building 1, the communications closet was disabled, and despite numerous attempts of announcements, there is no clear evidence that any of those announcements reached the occupants. With regard to Building 2, of the four instances that we list here, in the first instance, it talks about asking occupants to return to their offices. It's exactly at 9 o'clock. 2 minutes later, of course, they do talk about you may wish to start an evacuation. This was just before the building was struck by the airplane. And the two subsequent announcements, certainly the general trend is to talk about evacuation and not returning to their offices. So in some regards, the 9 o'clock announcement in hindsight appears was probably not the best, but all subsequent announcements did focus on evacuation.
The 9:20 announcement doesn't make sense.
It's not.
This is after impact, saying if you wish to leave.
Yeah, it did not talk about going back to your offices. Is it the best instruction? I have firefighters in this room that probably say no, so it's probably not the best way to say it. Emergency responder operations, I think we're now moving to the first responders. Situational awareness was a big issue. I think people who were outside the buildings, who could view the building conditions and had good communications, the situational awareness was good. For those who were initially outside and went inside, they had difficulty maintaining their initial awareness after entering the buildings. And people who had spent a lot of time inside, particularly were working on the upper floors, and had poor radio communications, their situational awareness was poor. I think it's important to say that that of the 198 elevators that were operating on the tower portion of the buildings, only one elevator was functioning in each building after they were struck by airplanes. One from the lobby to the 16th floor in Building 1, and from lobby to the 40th floor in Building 2. And the stairways are filled with occupants. And it is important to note that for firefighters, the counterflow is important, because when you're a firefighter or a first responder going up the building, you have a steady stream of people coming at you constantly. So that is a problem, especially when you're trying to go up there with 50 or 100 pounds of gear on your back. We have actually talked to 27 first responders who were inside of Building 1, and And we found, we talked to one who had reached 44th floor and without equipment, and many others who were in the floors 20s and 30s and some in the teens. The average rate at which they were climbing the buildings was about 1.5 to 2 minutes per floor. 1.5 without gear, 2 minutes with gear. Now, that doesn't say anything about once you get up there, after you've gone 50 floors, how tired you are or how effective you are to do the job you got to do up there. So it doesn't even begin to count that. This is a very, very quick estimate of if you have an emergency in a building and the elevators don't function, which can happen if there's no power or if there's an earthquake or 9/11. Our estimate is that it will take between 1.5 hours and 2 hours for a first responder to get up to the 60th floor. Okay? So if you have an emergency on the 60th floor of a high-rise building, you have to wait for 1.5 hours to 2 hours if the elevators don't function. Radio communications in high-rise buildings. I think there are three key aspects that we need to think about when we think about radio communications in high-rise. Much of the focus, public focus, has been on interoperability. I think interoperability is certainly important, but it's probably one of several key issues. One of the most important issues is communicating within the challenging radio frequency environment of steel and reinforced concrete buildings. It's just electromagnetic wave propagation in such kind of environments, much like your cell phone. I'm sure you have had difficulty with different cell phones in different buildings. You have to go near the window. Same kind of problems. And that's a problem that needs to be worked on. Second is simply the scale of the operations. 9/11, the scale of operations were very, very large. There were about 1,000 emergency responders on site. They were trying to communicate on the same number of frequencies they always have, which is usually few. You can count it, but it's few. When you have 1,000 people trying to communicate on a few frequencies, it's a little difficult. Not everybody can communicate all of the essential information that needs to be communicated. And so people, after a while, there's a surge in traffic, there's doubling, messages don't get delivered. After a while, you sort of give up using the system and do what you have to do. And so I think the scalability of the radio systems is an important aspect here, as is the protocols and hierarchy by which the radio communications actually take place in real emergencies of this scale. And of course, lastly, the interoperability is among agencies, different agencies is important. We did analyze and have previously reported on the emergency communications extensively, and I think one thing which we had reported was the fact that we believe the radio repeater system, which by the way was located in building, on the rooftop on building 5, was actually functioning. It's still our belief that the radio repeater system was functioning. And it's certainly the use of that system developed in building 2 and was very helpful in building 2. In building 1, we know it was functioning because the radio test that had been done by the first responding chief officer there was recorded in the system. So we have a recording of the system. We know the test took place. But for some reason, the chief officer could not communicate adequately when he did the test, and a decision was made not to use the system. I think we can certainly accept the fact that even if the repeater system was functioning, the quality of communications in building 1 was inadequate. And that's possible for any number of reasons. And every one of them I would be speculating because I have no evidence to support any one of them. But there are a number of reasons why the quality, one of them could be just radio frequency, propagation issues. Other could be the repeater system handset was broken, the handset volume was not turned up. There's any number of things that could have contributed to the fact communications quality was not good in the building. And there would have been confusion. Let's assume even if the repeater system was functioning in both buildings and they were all using them in both buildings, it would have been hard for people to keep track of which building was communicating. You know, people in building 2 and 1, there was already some confusion in identifying the right building where communications was taking place. So we think again, I'm speculating. With regard to command and control, I've already mentioned that the emergency responders, including key incident commanders, did not have adequate information, nor did they have an overall situational perspective of the conditions in the building. In addition, the command and control was seriously affected by the lack of good communications. We are actually now going public with this sentence, the third sentence, which is not in your handout. It will be on the website and it is in the reports, that a preponderance of evidence indicates that lack of timely information sharing and inadequate communication capabilities likely contributed to the loss of emergency responder lives. And in fact, there's a lot of evidence to that effect. We have a specific statement that I've extracted from the emergency responder first-person interview. It said, if communications were better, more firefighters would have been saved. Lastly, I want to talk about mobility impaired occupants again. About 40 to 60 mobility impaired occupants were found on the 12th floor of Building 1 as they went down, as the FDNY and PD personnel went down and attempted to clear each floor on their way out. These impaired individuals had been placed on this floor in an attempt to clear the stairways. And this is an important issue with regard to how mobility impaired people are evacuated. And emergency responders were assisting roughly 20 of these people just before the building collapsed. Again, we do not know how many of this group lost their lives. Just as we had done before for the building performance, let me do the factors of enhanced life safety in 9/11, factors that could potentially have improved life safety. Since the buildings were, first off, since the buildings were occupied by only about 1/3 of the building's full capacity of 25,000 people, the egress capacity was adequate for those survivors seeking and able to use and reach the undamaged exits and stairways. Okay, that's the important one. Well, there was only 1/3 capacity. Second, functioning elevators in Building 2 enabled 3,000 people to evacuate, self-evacuate, without waiting for help from a co-worker or anything of that sort, they made their own decisions. Greater remoteness of the stairwells, the impact areas of Building 2 enabled at least 18 people to use one of those marginally passable stairwells in that building. As the participation in the fire drill and the instruction about the location of the stairwell is another factor that probably contributed to a positive outcome. Upgrades made to the life safety systems after the 1993 bombing, such as the photoluminescent markings and emergency lights in the stairwells, and some other changes that were made in the evacuation routes, and signs that were posted on the evacuation routes. And one more factor is the evacuation assistance provided by emergency responders. This is the specific assistance provided to specific building occupants in the process. So it was a combination of these factors that contributed to approximately 87% of the tower occupants and over 99% below the floors of impact to evacuate successfully. With regard to practices and technologies that potentially could have improved life safety, again, we're talking future practices, improved performance to delay or prevent collapse. We have identified some of those when we discussed the building performance. improved stairwell integrity via increased remoteness of the stairwells and or enhanced structural integrity of the stairwell enclosures. In the towers, the enclosures of the stairwell were made of gypsum wallboard. And in fact, unlike many stairwell enclosures which have gypsum wallboard on 2x4 framing or some kind of a metal framing, in this particular case there was only a gypsum wallboard, interlocking gypsum wallboard, 2-inch thick, if I'm correct, without any 2x4 framing at the back of it or metal framing. Better communications to occupants and among first responders via improved systems and timely information sharing. Better command and control for large-scale incident management. That includes location of command posts and physical assets. For example, if you have a building struck by an airplane, and I hope it never happens again, do not locate your command post in the lobby of the building, located outside the footprint of where the building could fall. Or if you have a building with multiple floor fires, like 5 stories of fires, massive fires, maybe you want to locate your command post somewhere else. Better evacuation training, letting people actually evacuate, practice stairwell evacuation so they become familiar with the escape routes. Probably informing people that roof rescue is not presently feasible as a standard option. Probably informing people of any existence of transverse hallways in the stairwell system. Other life safety features could include fire-protected and structurally hardened elevators available for occupant use during emergencies, vibration-protected elevators, self-evacuation capability for mobility-impaired occupants. And that might be very important because right now you rely on co-workers or somebody else, and when you are in an emergency situation like a 9/11, or very often the co-workers are as concerned about their own safety, and so I think we need more assured procedures for the mobility impaired and operational smoke and fire control systems. I'm going to pass the next few slides pretty quickly. As far as procedures and practices concerned, the Port Authority did have an unusually comprehensive condition and structural inspection program in place that you don't find for most commercial buildings in the United States, for sure. And this program, systematic program, was implemented in the 1990s, although it started in the late 80s. The overall results were that the structural systems of these buildings were in good condition. The inspection consultants made numerous routine and some priority recommendations for repairs to the Port Authority. The reports did identify some of the same deficiencies from report to report, including missing fireproofing of structural steel members. But we don't know if these repairs were made or not because all of the inspection records were lost. But most of the regions where the fireproofing was reported to be missing was in the floors below the plaza level and in the hat truss zone, which is way on the top. There were also some missing in the elevator, in the components near the elevator shafts. But a large portion of that happened at the lower levels of the building. With regard to the structural integrity of the egress, I think the only thing I want to say is that had there been a minimum structural integrity requirement to satisfy normal considerations of safety, it is conceivable that the damage to the stairways and the towers above the floors of impact may have been less extensive. So in summary, with regard to the codes and practices, I think the codes that were used in the design of the towers, the 1968 code, was comparable to other codes of the era. We looked at Chicago, which is where the Sears Tower and John Hancock building were built. We looked at New York State, which is the region surrounding the immediate city area. And we looked at the national model code that governed the eastern seaboard, at that time, and they were all comparable in what was required in the code. The documents suggest that the towers were generally were designed and maintained consistent with the requirements of the 1968 building code. There were some areas of concern that included the fireproofing of the floor system, about which we have previously reported and will release more reports in June. The height of the tenant separation walls, and egress requirements for the assembly use space on windows of the world and top of the world. But those are described in the larger set of slides, the concerns we've had, but those were not of significance on 9/11 because the number of occupants on those two upper stories was well below anywhere near the capacity of what those floors could accommodate. So, and the number of people known to be there was relatively small. They did have a rigorous process, Port Authority, with regard to modifications, alterations made to the buildings through technical criteria, standards, and documents. All of those are documented in these reports. And they developed and implemented, I talked to you about the facility condition survey. With that, I'll conclude. I think again, the main message here is we have released 15 of the 43 reports. The technical work on the towers is complete. We have at this point told you what we think is the probable collapse sequence, or what we have analyzed and found to be the probable collapse sequence of the two buildings. That's our final finding with regard to the collapse sequence. And we have released 3 sets of reports associated with the evacuation, the emergency response, and codes and practices. And we aren't making any recommendations at this point, but in June we will come out with the remainder of the reports and recommendations. Thank you very much.
I'm going to walk around with a microphone. If you could ask your question fairly concisely, we'll try to get a number of questions answered. 1, 2, 3.
What was the cause of the fire in the World Trade Center Building 7?
There were several things that happened. At 10 o'clock, the fire alarm system in Building 7 went off. We aren't sure if it was because of a fire or because of dust, but we think that was the time when Building 2 collapsed, and it certainly probably inflicted some effect on that building. We can be more sure that when Building 1 collapsed, which was closer to World Trade Center 7, that by the end of that process, we know there was substantial damage on the south face of World Trade Center 7, particularly in the center toward the bottom 10 or 15 floors, and a region about 20% of the depth was scooped out, and that's a pretty large area. There was also damage on the top and the southeast corner. We feel that in the process of doing that, there might have been fire ignited in certain parts where our current hypothesis for that is that on floor 5 there was a pressurized fuel line. That was the only, as you know, there were a lot of day tanks in that building for emergency power generation, but there was only one floor where there was already a pre-existing day tank, so they had to use another system to get fuel there, and they used a pressurized line with tanks at the bottom. And we have, our hypothesis is, again, working hypothesis, is that it's that pressurized fuel line that was supplying hydrocarbon and somehow it ignited. How it ignited, we don't know yet, and we may not know.
I just have a quick question about the difference in the time between World Trade Center 2 and 1 collapsing. Based on what you said about fireproofing, it sounds as if the difference in the duration of those towers standing after they were hit is more related to how the airplanes went into the buildings than the difference in the thickness of the fireproofing in the two buildings.
You are correct. The thickness of the fireproofing had no role in the time duration of the building collapse. I think the manner, the type of damage caused by the airplane impact was a factor, certainly. Second was the time it took for the fire to spread from where it started to get to the point where it finally got to before it collapsed, which in the case of building 1 took a while for it to get to that south face. In the case of building 2, it was right there and persistent, made a difference. Those were, I think, the two primary reasons.
Sir, I'd like to ask a couple of questions about the connectors, which you mentioned in several places in the report. One in the back section, so you said the connectors had broken, the walls wouldn't have buckled. And yet, in the beginning of the report, you have here about 20% of the connections to the south perimeter wall in floors 97 and 98 failed. Now, that's the only real place that you said anything failed. Buckling isn't really a failure. It is, but it's not a breaking. There were bolts that were holding the trusses. Were the bolts sheared or were the trusses sheared?
We actually model all of the bits of connections in very, very great detail. And just to start, we have to be very clear that on the external faces, the trusses had 2 bolts. In addition, they were welded. The truss plates were welded to the external columns using weldments. In addition, they were braces that connected the columns to the trusses. So it was a bunch of welds in addition to the bolts. On the interior, it was 2 bolts.
60-foot truss,
yes,
held up with 2 bolts.
And absolutely. And we have looked at the design loads. We've done calculations on the design loads on each floor. And we've looked at the capacities of the connections on each side, both under vertical load and under pull forces. In all cases, they are much greater than the loads for which they were designed. Significantly greater.
A sagging floor really doesn't increase the weight of the floor.
That's correct.
Why would it then put a pull onto the outer columns if you haven't really increased the weight of the floor until the floor above it collapsed onto it?
No, because if you have a floor that's at room temperature, it's got what's known as bending stiffness. So all it's doing is resting on the supports and providing vertical loads, when shear loads. When you have heat and this thing is becoming soft like a string, it is actually pulling, because it's like a catenary. It's changing from a bending system to a catenary system, and a catenary always pulls. And so it's the same weight. It's not, but the same weight acting like a catenary, and catenary pulls the supports.
Are you saying that before?
It's like your clothesline. You put lots of clothes in it, it pulls the stuff.
I have one question over here, and then I got another one in the back, and then we'll just vary. We'll go here and then here.
Thank you very much. There's a couple of pieces of information I wanted to put on the table, one of which I think has been confirmed, another one has not been, and then ask a question. Peter Lance, who's won multiple Emmys, come out with a book called Cover Up, and he talked to me about a man who was arrested coming out of Building 7. He was wearing a New York Fire Department jacket. He was talking in Arabic on a cell phone. He was arrested. I'm unclear about exactly what happened to him. Also through a woman who used to work in the security division for the U.S. mission to the UN, who I met, who worked on a film called Panama Deception by Barbara Trent, told me of meeting 2 security personnel who stopped 2 firemen at 7:30 in the morning on the morning of September 11th that looked suspicious to them. Several had already gone into the building. I was wondering if you had heard any accounts of these firemen that weren't perhaps firemen. Then, in light of the fact that there were numerous eyewitness and ear witness accounts as to explosions, including by New York Fire Department personnel, who described a boom, 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 boom kind of explosive sort of description, and I've seen this on video. You say some of the challenges you addressed include competing collapse hypotheses. Did you look at the hypothesis of these suspicious characters who were apparently in the area, perhaps being involved in placing explosives in any of the buildings? And if so, did you look and do any traces? Were you given access to whatever was recovered and being able to do explosive residue testing or interview witnesses? Did your interviews include questions about explosives and the sounds and that sort of thing? So did you examine that hypothesis thoroughly?
Well, yeah, we looked at the visual evidence, the video evidence, and so forth. We have the physical evidence of the steel. By the way, our work was preceded by the Federal Emergency Management Agency and their team of experts, as well as the Structural Engineers Association of New York, which actually sent a large number of volunteers to look at the salvage yards from where the steel was selected. From all of those experts who looked at all of the steel, and some of which we have witnessed, not all of it, we have found no evidence of that would suggest any kind of an explosive material that caused the buildings to collapse. We have, in fact, everything we are showing you here with regard to the inward going is a time-dependent process. It is not related to an instantaneous inward going. The perception of a controlled demolition or explosion appears because once you start the gravity process once the top floor moves in and you start the pancaking process, what's happening is that's 15 seconds. You have something like 80 to 90 floors all going in 15 seconds. That means per floor you have a fraction of a second, and all of the air void between two floors are being squished in a fraction of a second. And all of the concrete that's on that floor, and all of the furniture, and all of the gypsum wallboard is being powdered instantly. And in fact, so you have the jet of air and pulverized concrete spewing out every time a floor hits the floor below it. And it would give the impression of a controlled demolition in a classical sense. And I think that's our belief, and that's where our findings have led us.
Did you ask other witnesses of these questions? Did you hear explosions? Was that part of your...
No, that was not a part of our request as far as the interviews were concerned. But none of the first-person interviews that we ever talked to ever brought up that issue on their own, because the process of the interview, especially with first responders, was very, very structured. The first question was, tell us what happened on 9/11 from the moment you got involved in the process till the buildings collapsed. And after they finished their story, we then asked clarifying questions, and then had some of our own probes in certain areas to see if they had information, but we did not probe them on this particular issue.
Sir, what about building sprinklers that we know were retrofitted into the World Trade Center after the '93 bombing? Do you have any information on where they were working and whether they were severed above the crash site?
There will be a whole set of reports, a whole report on the sprinkler system. I think the slides that are on the website do include all of that detail. The capacity, the sprinkler systems were designed with a capacity about 3 times the normal design capacity of sprinklers. So, as you know, most sprinklers, I assume there's something here. If there are sprinklers I can't see it, so. All right, okay.
They're there.
Oh, there they are, okay. The square foot per sprinkler, the sprinklers, the water supply to the sprinklers covers about 1,500 square feet. 30 by 50 room is what a sprinkler water supply is capable of putting a fire out. Now, the Trade Center towers had capacity to deal with about 4,500 square feet. One floor of the Trade Center was 40,000 square feet. So if the entire floor were on fire, there wasn't enough capacity of the sprinkler to put the fire out in the entire floor, not leave alone 4 floors. So the scale of the fire was very large compared to the design of the sprinkler system to begin with. But we also do know that because of the airplane impact through the core, the water supply to the sprinklers were broken. And so we had reports of water leaking at multiple floors. And I suspect, in retrospect, you could probably do, and we are going to talk about designing sprinkler systems with adequate redundancy and so forth. But again, keep in mind, buildings are not designed to withstand airplane impact. It's much more effective to keep terrorists away from planes and planes away from buildings. Otherwise, we'll be turning our cities into fortresses. And but for regular emergencies, we need to have them redundant.
And sir, I know Mr. Silverstein's building 7 World Trade now with an A and a B sprinkler line. Let's assume, hypothetically, World Trade Center had that. Do you think it might have stopped the collapse in that time frame, or slowed it down?
If the sprinklers what?
Say they had an A and B sprinkler line is now being put into practice. Do you think that might have prevented the collapse, say, within an hour or so, slowed it down, perhaps?
I would be speculating. You have to look at the specifics of the detail, the specifics of the airplane impact, and then figure out if they would have survived.
One question here, then one here, and then here.
Thank you. I am wondering about one issue that seems to have been omitted entirely from the purview of the report, which is the air toxicity issue in the days after September 11th, which obviously is a life safety issue. You know, there were a variety of assurances by the government that the air was safe to breathe, and these appear, and that no special precautions needed to be taken by the residents of Manhattan or first responders, and this appears to be rather dubious, especially in retrospect, given all the additional pulmonary cases compared to before. Why isn't this covered under your purview, I'm curious. And the other thing I was wondering about, just to follow up on this, on these theories about explosives. I saw on page 11 you have one core column from the impact area, and I'm wondering, you know, possibly because so much of the metal had been scrapped previous to your doing the report. I'm wondering, did you do any explosive residue testing on any item out of the building just to lay these ideas to rest?
Answer to that is no. We did not do it. We have a lot more core columns than the ones that we have shown you in that picture. A lot more, but again, it's a very small fraction of the steel. Just think about it. There were 200,000 tons of steel in those buildings. And even if you just took 5 floors of each building and took the steel and picked, assuming you had all the time to pick it. By the way, our investigation started 11 months or 12 months after 9/11, after Congress appropriated the funds for us and gave us the authority to conduct this investigation. If we were doing this all over again and we had access to the site and the authorities we have now, we probably have looked at the steel a lot more carefully and picked pieces of steel that we wanted to pick, but we don't have that luxury in hindsight, so we haven't looked at it. What was the other part of your question? I'm sorry.
Oh, about the air toxicity.
The air toxicity, that was important. That is important. Our authority is for under the National Construction Safety Team Act is we are much like the NTSB for transportation. We are that for building failures. So our main focus here is on building and fire safety and the safety of the occupants of those buildings. after the building collapses, that's not part of our charge. The Environmental Protection Agency has done studies with regard to air toxicity, and I think you should really be following the report that they have released with regard to that. And if you have concerns in that area, that's the right agency to deal with.
Thank you. I'm curious if perhaps you could address how the steel core at the base was molten and that the fires burned for more than 100 days. And please excuse me, I'm sorry. I happen to know a little bit about steel. I own shares in Bethlehem Steel. And I am involved in other matters related to steel refining and things like that. Steel molten at the base, at the core, and the failure of the core was simultaneous with the structure. So if you could address that, and then another concern, the FBI on the morning of 9/11 at the NBC building admitted to an administrative assistant of an outplacement firm that I used in the NBC building that there were explosives in the NBC building, and that building was cleared.
In which building?
The NBC building in Midtown in Rockefeller Center. And that there were explosives in the World Trade Center, and she was to get her things and she was to go home. And I heard the demolition hollow out the interior of the U.S. Customs House, which is 6 World Trade. Now, the government alleges that U.S. Customs had seized hazardous materials, and that the theory of the government was that the fuel from the first plane had flowed into the basement where these hazardous materials allegedly were poorly stored, and that the spontaneous combustion blew up 6 World Trade Center. So has there been deconstruction on this since? Because the photos really don't at all support what the government has alleged.
Well, the predecessor study to us, which is the FEMA study, which was done by private sector experts under contract with FEMA, they actually looked at not only the towers and World Trade Center 7, they looked at 4, 5, 6, and 3. They actually visited the site right after 9/11, the weeks immediately after 9/11. There is no evidence of multiple experts with regard to anything to do with explosions or explosives.
But you said you didn't test it all for that, though.
Excuse me?
But you said to the other question that you didn't test actually for explosive residues on the materials.
Yes, but when you see fracture of elements, you can make out if fractures are explosive in nature or if they're fractures due to mechanical effects. And explosive fractures have a very different characteristic. You don't have to see explosive residue. It's the nature of the fractures on the steel that you can see. And as I showed you the pictures on the north face of Building 1, we had very, very clear understanding to enhance photographs of what exactly those fractures look like. With regard to explosives are not, we do know there were some organizations in Building 7 that might have had some kind of explosives. We don't know what explosive there were, but we have no evidence in all of the 150 hours of video or of the photographs through careful study of any evidence of missiles going around or things of that nature. We just don't have that evidence. And with regard to the cauldron, so to speak, at the bottom, keep in mind that once the buildings came down, the fires were only on 4 or 5 floors, and once the buildings came down, there were additional secondary fires that might have been generated because of emergency generators, through oil, fuel, gas lines that were there. There's all kinds of things that could have fueled those fires. And once you have it all falling on top of each other and insulating, you have a large layer of steel, 200,000 tons of steel covering the spot. So if you had a fire inside, that heat would be entrapped for a long period of time. So you could see higher temperatures in local areas inside than you would see in the air. Building fires are known very well. Most building fires, temperatures on the order of 1,000 degrees Celsius.
One here, one there.
Yes, one of the things that has concerned me is something you will be dealing with later, is regarding number 7, is that Mr. Silverstein supposedly was on a PBS documentary said that he had said pull it with respect to building number 7. And, to me that means that demolition was used, and if they had the time to put explosives in number 7, then they probably had time to put explosives in the other tower. That doesn't necessarily follow that it's happened, but it's a great cause for concern. I assume you know that half the people of New York City in the Zogby poll in August believed that the federal government knew the catastrophe was coming and did nothing on purpose. And so you have a big challenge. I mean, you can, simply say, well, this is our theory and this backs it up. But you'd be doing a bit better service to the public if you actually, as you have done here, in concise words, deal with the critiques in full, and even reach out to the people who are afraid to put their names on their commentaries in the internet. I mean, they may not have proper credentials, but they may just be worried that their boss is going to fire them if they admit that that's them. And the Keene Commission didn't deal with all sorts of questions, but they're professional politicians. Professional politicians use blue smoke and mirror. You're an engineer scientist. You're supposed to know better. I urge you to deal with the explosion critiques as fully as you possibly can, not right this second, but in general.
I think your suggestion is well taken. We are making every effort, maybe not as proactively as you'd like, but we take your point and we'll consider it seriously as we go forward. I do want to say that the March issue of Popular Mechanics had Popular Mechanics, right? Popular Mechanics.
Chertoff's cousin.
Tried to address that. Excuse me?
Chertoff's cousin.
Who's that?
The new head of Homeland Security's cousin wrote the article.
Oh well. I didn't. I have no clue who wrote the article, but.
The arm's length here.
Next question.
Yeah, it seems like the core columns have been kind of indicted along with the floor trusses, in terms of causing instability of the exterior columns. What was that conclusion based on, seeing as how there was no visual observation?
We have not indicted any member as contributing to the collapse. What we have said is the airplanes that hit the buildings caused sufficient damage to the fireproofing that the fireproofing was dislodged, and even any other building design, if the fireproofing had not been dislodged, the building would have been fine. The floor trusses were fine, the columns were fine, and so forth. So that's the main message here. Now, did any one element contribute to the collapse? Probably the answer is no. That means if the columns had not been stripped of fireproofing and had weakened, or the core had not weakened, and just the floors had sagged, probably the buildings may not have collapsed. And so if you take one by one, it wouldn't have had an impact. It's the collection of things that happened. The weakening of the core, the sagging of the floors, and the weakening of the exterior columns that together led to the collapse, based on our analysis. That's correct.
We're going to take 2 more questions back there, and then one here.
I don't need a microphone. Based on your analysis, what could have been done, or what do you think could have been done, or in the future, to protect people on floors that are very high up in high-rise buildings, where perhaps they're above the fire?
Well, first of all, I hope there's no other time when we have to deal with an airplane impact. That is not a normal situation that we should be even speculating about, because that's a no-no. But if in fact you were in a situation where there was a normal building fire and you were above an impact, most of the times in a building, if you had fire-protected and structurally hardened elevators, that can help. If you had...
Isn't that against the code in New York City?
Well, it's actually not permissible. In the late 70s, we did research in the United States at NIST and with United Technologies to look at, which is Otis elevators, to look at these kind of technologies. So the technology exists. and it's actually required. Firefighter elevators are required in the United Kingdom. Right now, they're not required in the United States, and Dick Bukowski here is working with the elevator industry to make it possible for such kind of systems to be used in the United States. So right now, you are right. The current systems cannot be used, but the technology exists for us to begin to start bringing that technology into practice.
But if you had that technology on 9/11 in the World Trade Center, for instance, Tower 1, do you think any of those elevators would have worked? You had said earlier they were all knocked out.
Yeah, well, it's quite interesting. When I said only one elevator was functioning out of 99, remember, this had a sky lobby system. This was like 3 high-rise buildings. And the effect was the impact damage was only on the 3rd level of the high-rise, the top 3rd. So there were elevator shafts that had ended long before it got to the 3rd level. There were elevator shafts in the 1st zone and 2nd zone. All of those elevators were stopped. And even including things that went from the 1st to the 15th floor or the 20th floor. So had there been, and I use the term fire protected and structurally hardened. There are 2 separate things. Most of the time we think protected means fire protected. Yes, if it was just purely fire protected, it might have helped. But if it's fire protected and also structurally hardened so that the impact of the structure itself also could be withstood, yeah, you would have probably had much better performance of those elevators.
All right, final question, please.
All of those things do involve costs, so they're trade-offs.
Could you indicate whether something like the Sears Tower, which is also a very tall building, if it were hit, would it react in the same fashion, or is it just the function of the particular structure of the World Trade Center building? Empire State was hit by an airplane at one time, and it withstood everything.
Yeah, I would be speculating. I think what I've learned, what our extended team has learned after 2.5 painstaking years, is that it is awfully hard to make these analyses, and it does require the entire analysis to happen before you can make conclusions. So each case has to be looked at by itself, and you have to you've got to do the analysis for it.
You had talked in some of these papers about compartmentalization of the structure, but if you had, instead of just a core and a periphery, if you had other structures, vertical structures in the building, would not that have stopped the collapse of this nature?
Again, I don't want to speculate, but just let me give you a sense. One of the things about this building was that the cross-section was very wide, so it could swallow the airplane. If the cross-section is narrow, what happens then? Well, you said that. I didn't say it. You would have to analyze it. So, this is all not, we have to analyze this. We don't know. Okay.
Shyam.
All very good. Thank you very much for your patience. Appreciate it. Yes, absolutely. And we